Hello everyone, welcome to eMed School, your virtual medical school. Today in this video tutorial, we are going to talk about Bohr's effect. We'll be focusing on its introduction, regarding its mechanism, and also the significance of Bohr's effect. So, this video is going to be short. Please watch till the end and don't forget to give your valuable feedback at the end. This shows the structure of hemoglobin. Hemoglobin is composed of two alpha beta dimer, alpha beta. So there are two such kind of dimer, one alpha beta dimer and another alpha beta dimer. Each hemoglobin can carry 4 molecules of oxygen. So each hemoglobin can carry 4 molecules of oxygen, 1, 2, 3 and 4. Now in Bohr's effect we need to learn that when the partial pressure of carbon dioxide is increased or when the pH of the blood falls. pH falls means acidity is increased in H plus ions. So when the partial pressure of carbon dioxide rises or the pH falls or the concentration of H plus ions, protons increase, then the oxygen molecules bound to hemoglobin is released. So this is what we call Bohr's effect. I'll repeat it once again. When the partial pressure of carbon dioxide rises, when the pH of the blood falls or the concentration of hydrogen ion increases, then the oxygen molecules bound to hemoglobin are released. Now we saw oxygen bound to the hemoglobin, they are released to the tissue, and the structure of hemoglobin has also changed. The hemoglobin, the alpha beta dimers in hemoglobin, the alpha beta dimers, they have approached toward each other. Now they are in the tense configuration. Earlier they were in the relaxed configuration. This tense configuration is the deoxy form of hemoglobin, and earlierly it was the relaxed or oxyhemoglobin. So we knew what Bohr's effect is. Bohr's effect is as simple as that. When the partial pressure of carbon dioxide rises or the acidity increases or the pH of the blood falls, then oxygen molecules that were originally bound to hemoglobin is released. So Bohr's effect is as simple as this. Now we'll see the significance of Bohr's effect. Okay, now first let us start about the mechanism before the significance. So how does the increase in carbon dioxide or the increase in H plus ion cause the release of oxygen molecules bound to hemoglobin? That is the question. Now I'll be answering this question. So carbon dioxide binds to water and forms carbonic acid, and the enzyme involved is same that we discussed time and again, carbonic anhydrase, the same enzyme that was involved in the chloride shift. You can check out the video on chloride shift. I have given the link at the description box. So carbonic acid then splits into carbonic acid now splits into H plus and HCO3 minus ion. So carbonic acid splitted into proton and bicarbonate ion. So now we can see whether it is a rise in carbon dioxide or it is the rise in the proton or H plus ion concentration. The thing is going to be the same because the central character playing here is the H plus ion. Now this H plus ion binds to oxygenated hemoglobin. When this H plus ion binds to oxygenated hemoglobin, then oxygen molecule is released and this oxyhemoglobin gets converted into deoxyhemoglobin, and that's the job done. Oxygen is released from the hemoglobin. Why? Because of the increase in concentration of H plus ion. Why? Because of the carbon dioxide. So increase in partial pressure of carbon dioxide. So I hope you are clear with the mechanism of Bohr's effect. Now we'll finally go into the significance of Bohr's effect. Lungs is supplied by pulmonary capillary. When you zoom into it, so when we inhale a lot of oxygen in our breath. This oxygen, this oxygen has to diffuse to the pulmonary capillary, and this pulmonary capillary, the oxygen contained in the pulmonary capillary is carried through network of blood vessels up to the tissue capillary. Now, the work of hemoglobin is to carry these oxygen molecules. These oxygen molecules are not only in the dissolved state. In fact, the dissolved oxygen accounts for a very tiny fraction, only 3% of the total oxygen transported. So most of these oxygen molecules, they are bound to hemoglobin, and when these oxygen molecules reach up to the tissue level, these oxygen molecules have to be released for the metabolic processes inside the cell. So now the Bohr's effect comes into play. In the tissue capillaries right here, the pH of the blood is low, and also the partial pressure of carbon dioxide is high. So this is the ideal condition for Bohr's effect to occur. So hemoglobin releases the oxygen bound to it, and finally that diffuses into the tissue. Now you must have realized the significance of Bohr's effect. The significance is that it causes the unloading of oxygen. So hemoglobin is a carrier, and the role of carrier is to transport something from one place to another. So at the time of loading, it has to combine that thing, it has to bind that thing, it has to carry that thing, and when it gets into its destination, it has to release that thing. Otherwise, there is no role of carrier. So hemoglobin, as a carrier of oxygen, has played its role at the tissue level. It releases the oxygen molecules so that it can be used by the tissues for the metabolic processes. So in this video, we discussed about what is Bohr's effect, what is the mechanism behind Bohr's effect, and finally we also talked about the significance of Bohr's effect. I hope you like this video. Please give a feedback on the comment section. This is the end of this video. If you think this video was helpful, please give it a like, share, and also please don't forget to subscribe. I'll be coming up to you with new videos. Please write in the comment section, give feedback about this video, and also write what you want me to make next video on. I'll be coming up to you with next videos. Thank you for joining with me in this video. Thank you so much. Bye bye.